Hey, welcome to Draft Academy. My name is Mike. This video is part of a series of videos where I'll be going over the basic syntax of different programming languages. Now, one of the most annoying things about picking up a new programming language is having to learn all the syntax from scratch. In my own experience, it generally manifests in a lot of Google searching and Stack Overflow. For an experienced developer, the problem isn't understanding the concepts of programming, it's knowing how to implement those concepts in the new language. So things like variables, data types, data structures, loops, conditionals, and object orientation. All of these things are done a little bit differently in each programming language, and having to research how to do it all can be extremely annoying and tedious. In this video, I'll go through and show you the basic syntax for the most common parts of the language. I'll give you a brief history of the language, and we'll touch on some of the best practices and conventions used in that language. Now, this is meant to be a quick run-through. I won't be showing you how to install or configure anything, and we won't really have time to learn how to do everything. You see, I've distilled it down into what I consider the core concepts, so the goal for this is to be a quick video, so I can't cover every aspect of the language. With that being said, this video is meant for programmers who already understand the core concepts of programming. It's not going to teach you any programming concepts. I'll simply show you how to do all the common things in the new language. So if you are new to programming, Draft Academy has hundreds of videos where I hold your hand and I walk you through everything you need to learn to program, but this is meant for developers who already understand programming. So without further ado, let's get started. C# is a general-purpose, statically typed, object-oriented programming language that was founded in 2000 by Microsoft as part of their .NET initiative. C# was designed to be portable and fast and is tightly coupled with Microsoft's .NET framework. It was created alongside the .NET framework in the late 90s. C# is one of the most popular programming languages in the world and can be used to write applications on almost every platform, including Windows, Mac, iOS, Android, and Linux. In fact, more and more people are using C# to write cross-platform apps every day because it allows for a shared code base across platforms. Basically, you could write all your backend business, logic, and database management code once and use it on your iPhone, Android, and desktop. All C# code is compiled down into an intermediate language called Common Language, which is then translated and executed by the .NET runtime, also called the Common Language runtime. This ensures that C# programs can be run on virtually any combination of hardware and operating system. The underlying C# runtime uses an automatic garbage collector to manage memory, and the syntax of C# is largely influenced by Java. Most developers choose to write C# using a specialized integrated development environment called Visual Studio. Visual Studio is an IDE that's maintained and developed by Microsoft, so it's the best choice and realistically your only choice for writing C# applications. In fact, most C# developers are going to use Visual Studio in some way, shape, or form. So in this tutorial, we are going to go ahead and look at some of the basics of C#. We're basically just going to look at all the common syntax and how we can implement some of the most common programming things inside of C#. Now, over here, I have my command line. This is where I'm going to be compiling and running all of my C#. And then over here, I have my text editor, which is where I'm going to be writing all of my C#. So you'll see over here, I have a basic skeleton, and this is just, it's called app.cs, and the CS is the C# extension. And over here, I'm just using a couple different things. So I'm using system and I'm using system.collections. Basically just means I'm importing different code. And I just need these in here because I'm going to be using some of the stuff from those libraries. And anytime in C# when we're writing code, we're always going to put everything inside of a class. So I have this class called app, and then in here I have this method. It's public static void main, and this is the main method. Basically, this is the method where I can put any code that I want to get run. So when I run my C# program, any of the code that's inside that main method will get executed. And because C# is class-based, generally we're referring to these as methods and not functions, although you can refer to them as both. So the first thing we'll look at is printing. How do we write something out onto the screen? And in C# it's pretty simple. We're just going to say console.writeLine. And I can either say write line or I can say write, and then inside parentheses, I can just put the text that I want to print out. So write line is going to print out this text, and then it's going to print out a new line after it. Write is just going to print out the text, no new lines. So you'll see over here the result of printing that. We get hello world with an exclamation point. Now let's talk about variables. Now, variables are basically containers where we can store pieces of information, and variable names in C# are case sensitive, and they can begin with a letter, an underscore, or an at symbol. Generally, you want to start them off with letters. That's kind of the convention. And then after that first character, we can have letters, numbers, or an underscore. Convention says that we want to start our variables with a lowercase word, and then additional words are going to be uppercase. So this is sometimes referred to as camel case. So I have like my first variable. You can see that it's named where the second and third words are capitalized. And C# is statically typed, which means we're going to have to rigorously define the data types of the variables that we want to create. So I'm creating some variables here. The first one is a string. It's called name, and I'm just storing a name. And strings are actually objects, so they're not actually like primitive data types. But you can create a string just with these quotation marks, and then we can also have a character, which is like a single 16-bit Unicode character. And you can see that with the character, we use a single quote just like that. And then down here, we have our numbers. So two basic types of numbers, whole numbers and decimal numbers. Whole numbers are integers. First is a byte. It's an 8-bit unsigned integer. Then we have a short, which is a 16-bit signed integer. The int, which is kind of like the default, is a 32-bit signed integer. And then we have a long. And you'll notice with the long, I'm putting a capital L here after it. That'll denote that it's a long. And it's a 64-bit signed integer. If you want, you can prepend these data types with U to make it unsigned. So I can put a U here, and that would mean like an unsigned short. And then down here we have our floating points. So floating points are decimal numbers. We start off with this float. It's a 32-bit floating point, and you can see I'm putting a capital F after here. That would signify that it's a float. We also have a double, which is going to be the default, and it's a 64-bit double precision floating point. And then finally we have a decimal, and you'll notice I'm putting an M here. That's a 128-bit precise decimal. So if you're doing anything with like money or something where you really need to be precise, then you want to use a decimal. But for the most part, people are going to be using doubles. Then finally we have our 1-bit Boolean, which is going to be a true or false value. And a lot of times you're going to name this starting with like is or are. So like is tall or are something, basically that's how you can name it. And if you want, you can just declare the variable and then you can give it a value, or like I did up here, you can just assign it a value right away. And we can also modify these variables just like I did down here. Then if we want to print out variables, you have a couple options. Your first is concatenation. So I could console.write line, and I could print out a string, and I could concatenate onto the end of it the value inside of the variable. Or if you put a $ here in front of the quotation marks, that means you can just interweave your variables just like this inside of curly brackets. And this is actually pretty useful. And a lot of other languages will do something similar to that. So you can see over here, we're printing out your name's John and your name's John. We can also have a constant. So I could come over here and say like const, like this const modifier. And basically what this will do is it'll make this a constant. And a lot of times in C#, we'll name our constants in uppercase. So it'll be like that with words delineated by this underscore. And now this constant, because it's a constant, actually won't be able to be modified. So that's just going to be like set as it is, can't be modified. Now let's talk about casting and converting. So we have all these data types. How can we swap data types or convert different data types to other data types? The first is with casts. So I have a floating point number here, and I can actually cast it to an integer. So I can just put int inside of open and close parentheses here, and then right after it the number. Or I can do the same thing for double. So this will cast this to an int and this to a double. You can see over here we get 3, and then this is still 3, but it's actually going to be a double now. And then also a lot of times if you have numbers trapped inside strings, you want to be able to get them out. So I have over here a string with a number inside of it. I can just say convert dot to int 32, and there's actually a bunch of these, like to int 32. You could also do like to double, or you could even do like to int 16 or stuff like that. Basically what this will do is it'll convert this into whatever we specify here. So we'll actually be able to convert this into a double and convert this into an integer. And then you can see I stored these guys inside of the corresponding variables, and then down here I'm adding 100 to them. So you can see over here we get 150 and 199. So it's actually able to do the math on those. So we were able to convert strings into ints and doubles. Now strings are one of the most important data types that we'll be dealing with, and everybody loves strings, everybody loves to work with them. So I'm going to show you guys some of the basics with strings. I can just create a string variable like this down here. Again, we're using the quotation marks, and strings start off with index position 0. So this is pretty common across programming languages. Even though H is technically the first character in the string, it's at index position 0. So there's 5 characters in this string, but the index positions end at 4 because we start counting at 0. And you can do a bunch of these different methods on here. So I could say like greeting.length, and this will give me the length, so we get 5. If I want to access a specific character in the string, I can just make these open and close square brackets and then put the index in there. So greeting 0 is going to give me this H because it's at index position 0. We can also do index of, and that'll tell us at what position a specific substring or character is in the string. So I have LLO, and index of LLO gives me a 2, and that's because LLO starts at index position 2. If you put in a string or a character here that's invalid, so that's not in the string, you'll get a -1. And we can also do like a substring. So I could say greeting.substring 2. And if I just put one number in there, it's going to give me the substring starting at that index and going to the end of the string. So starting at 2, we get LLO. If I put another number in here, this will give me a length. So it'll basically be start at index position 1 and give me 3 characters. So we get ELL, and that's why we get ELL over here. Now, there's a ton of these string methods. Obviously, I'm not going to show you guys all of them, but all the string methods that you would expect in a normal programming language, you're going to have access to in C#. You can just check out the API for more detailed information on that. Now let's take a look at numbers. So in addition to strings, we also have numbers are extremely useful in any programming language. So I'm going to show you guys just some stuff we can do with them. So over here, I'm writing out 2 times 3, and that'll actually do that operation for us. So we get 6. You can do addition, subtraction, division, and multiplication. You can also use the modulus operator. Modulus operator will take 2 numbers and divide them and give you the remainder. So if I say 10 mod 3, this will give me a 1 back because 10 divided by 3 is 3 with a remainder of 1. You can also specify order of operations. So generally, like if I have this equation down here, 1 plus 2 times 3, C# is going to do the multiplication first. So it's 3 times 2, 6 plus 1 is 7. We get 7 over here. But if I wanted, I could change the order of operations by putting parentheses around here. So I can put a parentheses around the 1 and the 2. And now when I run the program, instead of getting 7, we're going to get 9 because it's going to be 1 plus 2 is 3 times 3 is 9. And I also want to show you guys how ints and doubles are going to interact. So over here, I have an integer and I have a double. If I take this integer and divide it by a double, you'll notice that I'm getting a double back. So I'm getting a floating point number back. But if I take an integer and just divide it by another integer, so like 10 divided by 3, now you'll notice that we're just getting an integer back. We're just getting 3. So 2 floating point numbers, if they're added or multiplied or divided together, you're going to get a floating point back. If you have a floating point in an int, you're getting a float back. If you have 2 ints, you're getting an int back. And that's pretty standard across all programming languages. All right, so now down here, I'll show you some other stuff. So I'm creating an integer called num, giving it a value of 10, and I'm saying num plus equals 100. So plus equals is a shorthand for num is equal to num plus 100. So basically, this will take num and it'll add 100 to it. So over here, now the value of num is going to be 110. I can also increment it using this plus plus operator. So that can give me 111 because I'm incrementing the value of num. You can also use minus minus to decrement. And then down here, I just have some math methods. So there's this math class that we can use, and you can just say math, it's a capital M, dot, and then there's a bunch of methods. So like POW will give me the power, so it'll do 2 to the power of 3, which is going to be 8. Square root of 144 is going to be 12, and then rounding 2.7 will give us 3. And like I said, all the standard math methods or functions that you would expect are going to be available there. You can just check out the API online for a more detailed description. Now let's talk about getting user input. Now obviously in any programming language, there's tons of ways you can go about getting input, but in our case, we're just going to get input from the console over here. So I have, the first thing I'm doing is printing out a prompt. So I'm just saying console.write, enter username. And then what I'm going to do is I'm going to create a string. So I'm saying string username, and I'm going to set it equal to console.readLine. So unlike console.write or console.writeLine, readLine is going to allow the user to enter information into the program. So when I say console.readLine, this will allow me to enter something in. And I can just put my name over here, hit enter, and it says hello Mike. So it's storing whatever the user entered inside of this variable, and then it's printing it out down here. And you can use those conversions that I showed you guys before to get numbers, and obviously like you can build a little calculator or do something like that. All right, now let's talk about arrays. So arrays are extremely important. It's a data structure where you can store multiple pieces of information. So the way we create an array in C# is I can just say the type of information that I want to store, an open and closed square bracket, and then the name of the array. And if you want, you can give it some initial information. So I could say lucky numbers is equal to, and then inside of these curly brackets, I'm giving it some initial information. And just like strings, array indexes are going to start at 0. So the first element in the array is going to be at index position 0. If you want to access the elements in the array, you can just refer to the array's name, and then in square brackets, you can put the index of the element that you want to access. And so in this case, I'm modifying it, but you could also print it out like I did down here. So over here, I'm printing out lucky number 0, which is going to be 90, and then lucky numbers 1, which is going to be 8. You can also print out the length. Lucky numbers.length is going to be 6. Now, a lot of times you're not going to know what information you want to put inside the array right away. So we could come up here and do something like this. I could say int, again, square brackets, lucky numbers, and I could set this equal to a new int. And then over here, I need to specify how many elements I want to be able to store inside of this array. So in this case, this array will be able to store 10 elements. And if I run my program now, you'll see lucky number 0 has been given a value of 90, but lucky numbers 1, which we're printing out here, hasn't, and it just gets initialized to 0. So anytime you do something like this, all the array indexes are going to get initialized to 0 unless you or until you set them to different numbers like we did over here. And you'll see the length is 10 because that's the length that we specified right there. We can also work with n-dimensional arrays. So n-dimensional arrays are basically like 2, 3, 4, 5 dimensional arrays, something like that. Down here, I just have a 2-dimensional array just to kind of show you guys how this works. And I'm just saying int, and then instead of 1 square bracket, I have 2, and that's going to refer to the dimension. So 2 square brackets would mean 2-dimensional, and then number grid is equal to, and then in here I'm creating 2 arrays. So this is how I can initialize an array. I can just say new int, and then square brackets, and then inside of here, obviously like assign all the values. So I'm doing this twice, and then to access them, you can just refer to, this is gonna be the index position of the element in number grid, and this will be the index position of the element inside of the element. So 0, 1 is gonna be this 2 over here. So I'm setting that equal to 99. And down here, I'm printing out 0, 0, which is a 1, you can see up there, and then 0, 1, which we set to 99. Now I want to talk to you guys about a more dynamic array. It's called an array list, and this is actually a class inside of C#. But the array list is basically just an array where it's a lot more flexible than a normal array. One of the downsides to normal arrays is that you have to like rigorously specify how many elements you want to have in there. And this array list is going to allow us to basically just like dynamically add elements. And in order to use this, you're going to have to use include this up here using system.collections. And then down here, I can just say array list friends is equal to new array list, and then an open and close parentheses. And down here, I can use a bunch of methods on this array list. So I could add elements like friends.add Oscar, Angela, and Kevin. And then down here, you'll see that I'm printing out like friends 0, friends 1. So I'm printing out Oscar and Angela. You can also check to see if something is inside of the array. So I could say like friends.contains Oscar. And you'll see over here, we get a true back. So if Oscar wasn't in there, then we get false. And then we can also get the count. So that's how many elements are in there. If I wanted, I could remove an element. So I could say like friends.remove Oscar. And now this will go ahead and remove Oscar from the list. And you'll see down here, it says false because friends no longer contains Oscar. Now there's a lot more array methods. I mean, pretty much all the standard methods that you would expect in something like a dynamic array you would have in this array list class. Again, you can just check out the API for more information. Now we'll move on to methods. Methods are little blocks of code that we can call, and we can kind of reuse the code that's inside of them. So over here, I have my main method. And this is, like I said, it's a special method that is going to get called when we execute our C# program. But if you want to make other methods, you can. So down here below the main method, I created another method. And you'll see there's a bunch of like keywords before this. I'll kind of walk you guys through. Public is a access modifier. It basically determines what code can see this function. A lot of times you can just say public, and we'll talk about some of the other ones later. Static is another keyword. And actually, a lot of times when you create methods like this, you're not going to need that static keyword. We'll talk more about what static is later. But just know that if you're putting a method alongside of this main method and you want to be able to call it like I am up here, you're going to need this static keyword. And then finally, we want to put a return type here. So int is going to be the type of information that's getting returned from this method. If you don't want a return type, you can just say void, and that'll mean you're not returning anything. In my case, I'm returning an integer. So over here, I can just give this a name. And generally, the convention is that in C#, whenever you have methods, you're going to name them starting with a capital letter. So you'll see add numbers is capitalized. And then over here, I can specify some parameters that I want to take in. So like int num1, int num2. You can take in any data type, strings, doubles, booleans, whatever. And then down here, I'm just saying return num1 plus num2. You can have as much code as you want in there. This return keyword will return you from the function, and then anything that you specify over here is going to get returned as a value as long as you have the corresponding data type in the return slot right there. All right, so up here, I created an integer called sum, and I set it equal to the result of adding these two numbers. And then down here, I just printed it out. So sum is actually going to get the value of doing this, and then we'll print it out, and you can see we get 64 right there. Now I'll talk to you guys about conditionals. So first thing we're going to look at are if statements. If statements allow your programs to respond to different things. You'll see I have two booleans here, is student and is smart, both equal to false. And down here, I can write an if statement, which is going to respond to those two variables. So depending on the value of those variables, it'll do different things. I'm basically checking here if is student and is smart. You can use this double ampersand in order to check more than one condition. I could also use two vertical bars like that. It's going to stand for or. So there's and or. And then if this condition's true, then obviously we'll come down here and execute that code. Down here, we can also use else if. So that'll get executed if this isn't true. Then we'll come down here and check this condition. So I'm saying is student and not is smart. So here is the negation operator. It's that exclamation point. Basically, that'll negate a condition. So for example, these are Boolean. So if I said not is smart, it'll just negate that Boolean value. And then finally, we have an else. So that'll get executed when none of the above conditions are true. In that case, we were using Booleans, but you can actually get Boolean values by comparing different values. So over here, I can say if, for example, 1 is greater than 3. So, this comparison will result in a true or a false. It'll result in a Boolean value. So that's another way that we can define conditions. So 1 greater than 3, we can use greater than, less than, greater than, equal to, less than, equal to, not equal to, and double equals, which is going to be equal to. So if I said 1 less than 3, now this will be true, and we'll execute the code. So it says number comparison was true. And that's kind of going off the screen a little bit. So that's the basics of if statements. It's everything that you would expect from if statements. Another type of conditional that we can represent is a switch statement. And a switch statement is essentially just a specialized type of if statement where we can check one value against a bunch of other values. So over here, I have a character, my grade, it's equal to A, and I'm using this switch statement and I'm passing in my grade into it. Basically what the switch statement will do is it'll check to see if my grade is equal to a bunch of different cases. So I can say like case A, so this is in the case that my grade is equal to A, we'll come down here and execute this code. So console.writeLine, you pass. And then if you want, you can include a break statement here. That'll break you out of the switch statement. And then we also have another case for F, which is console.writeLine. And then we also have a default. So this is kind of like an else. Basically, this will get executed if none of these cases are true. And then you can put whatever code. But if you have a default, you always need to put this break there. So that's required. Otherwise, you'll get a compiler error. So for example, like since my grade is A, you'll see I'm getting you pass here. If I set this to F, ran the program again, you'll see it says you fail. If I set it to like a not valid grade like Z, now it'll tell me that. So it'll be able to respond to all the different values of my grade a lot easier than it would with like an if statement. C# also allows us to use loops. So over here I have a really basic while loop, and a while loop is a loop that'll keep looping through a block of code while a certain condition is true. So I have an integer index is equal to 1, and here I'm saying while index is less than or equal to 5, and then inside of these open and closed curly brackets, we can just put whatever code we want to keep iterating over. So I'm just writing out the index and then incrementing it. You can see we get 1 through 5. So once that gets to 6, then the loop terminates and we're no longer going. Always want to watch out for infinite loops. So if I was to comment that guy out, now we have an infinite loop because index is never getting incremented. So it's always going to be less than or equal to 5. So just keep that in mind when you're writing your while loops. And another type of loop, which is similar, is a do while loop. So a do while loop is exactly like a while loop, except the order is switched around. So in a while loop, we check the condition first and then we execute the code. In a do while loop, we execute the code and then we check the condition. So even if index up here was equal to 6, and you'll notice I have the same condition as I did in the while loop, I'm still going to be able to execute one iteration of the do while loop because we execute the code first, so I execute the code before I check the condition. And do while loops, and while loops are essentially the same thing, but in certain circumstances, you're going to want to use one over the other. So now we can move on to another type of loop, which is a for loop. For loop similar to a while loop, although it allows us to do a little bit more. So the for loop will allow us to declare a variable or define a variable that we can access throughout the loop. So here I'm just saying for, and then inside of these parentheses, I want to specify three things. The first thing is going to be a variable declaration or instantiation. So down here, I'm just saying int I is equal to 0. And then, so this is going to be like our indexing variable or our loop variable. And then I can separate it with a semicolon. Here I'm specifying the loop condition or the loop guard. So while I is less than 5. And then again, separated by a semicolon, we have I++. So that's going to be a line of code that gets executed after every iteration of the for loop. Down here, I'm just printing out console.writeLine. So we're printing out 0 through 4. So the loop executes 5 times. And these can be really useful, just when you want to loop a specific number of times. All right, so in addition to a for loop, we can also have like a for each loop. This is like what you call like an iterating loop. So I have a array up here of lucky numbers, and it's just all these numbers. I could say for each, and then I want to create a iterating variable. So this is going to be a variable that changes every time we go through the loop. So it's going to be an int called lucky num, and I can say int lucky num in lucky num. So this is the name of the structure that we want to loop through. In our case, it's an array. And down here, I can just say console.writeLine lucky num. So now when I run my program, we're printing out all of the elements inside of that array using the for each loop. So a while loop is a very general loop, and then we have a more specific for loop, and then we have an even more specific for each loop. So you want to use whichever ones are appropriate at the appropriate time. Now let's take a look at exception catching. So a lot of times in our C# programs, certain things are going to come up, exceptions are going to get thrown, and our programs are going to get terminated. But the question becomes, how do we mitigate that? How can we handle those exceptions? So over here, I'm going to spawn an exception for us. You'll see here, what I'm doing is I'm writing, this is like a little program which is going to allow the user to enter in a number. So I'm dividing 10 by whatever number the user enters. So over here, when I run the program, you'll see it's basically prompting me for a number. If I put a 0 in here, what this is going to do is it's going to try to divide 10 by 0. So this would be a situation where I'm trying to do a division, but I'm doing division by 0, which is invalid. So if I click enter, you'll see that we get this little message here. It says unhandled exception, system.divide by 0 exception. So actually, let me make this a little bit bigger. Divide by 0 exception. So we get a specific exception. So what I'm gonna show you guys how to do is mitigate that so we can use like try catches. So let's get rid of this. And down here, I basically took that same line of code and wrapped it up in a try catch block. So over here, it's basically saying same thing. This is the same exact line up here. I'm prompting the user to enter a number to divide. But down here, I'm saying catch, and I'm specifying the specific exception that got thrown. So right here, what this is going to do is it's going to catch the divide by 0 exception. So I'm specifying the specific exception. So now if a divide by 0 exception gets thrown, we'll execute the code down here. But if any other exception gets thrown, then this won't get executed. And then over here, I can just put exception E. And basically, this is going to catch like any exception under the sun. So if you wanted your program to be like completely bulletproof, you could put something like this. And you can put multiple catch blocks like that. Now, generally, just putting the general exception here is a bad practice, just because it's going to catch everything. And a lot of times, you don't want to catch everything. You're going to want to, only catch specific things or do specific things when certain exceptions occur. But the point is now when I run my program and I put a 0 in here, it'll catch it. But you'll notice that it didn't crash. Like I'm printing out obviously E, which is the error, but I could also print out like, something random. And now if I entered in a 0, it just prints out hello. So I'm able to prevent the program from crashing. So that's how we can catch exceptions, but sometimes you're gonna wanna throw exceptions. So for example, I could throw a division by 0 exception. I could say throw new divide by 0 exception, can't add numbers. This is just gonna be like the message. And these are actually classes. So if you just kind of look up like the exception class in C#, these are all subclasses of that. So now if I run my program, we're actually gonna throw an exception. We'll throw that exception. You can see the app stopped working, and that message that I typed out is can't add numbers. So that actually got displayed as well. So that's kind of how we can work with exception catching. Now I want to talk to you guys about object orientation. So we're going to look at the ways that we can use objects and classes and stuff like that in C#. Now C# is a fully object-oriented programming language, which is awesome. You can do everything that you could normally do in an object-oriented programming language. So up here, I actually created another class. Now I have class app over here, and then up above it, I created another class. Now, a lot of times in C#, when you create a class, you're going to want to put it inside of its own file. In fact, that's like generally a best practice, is to put each class inside of its own file. For our purposes, I'm just putting it up in the same file so it's easier for us to see. But we basically just say public class book, and you could also put private here. And we'll talk about what private does in a little bit. But generally, classes are all going to be capitalized, just like book is up here. So this is a class that would represent like a book. And you can see we have a couple attributes here like title and author, and these are both strings. And then I also have a static attribute. And a static attribute is an attribute that belongs to the class. So both of these attributes are what we would call like instance attributes. So these attributes will belong to a specific instance of a class, but the static attribute belongs to the class itself. And then down here we have a method, which is just public void read book. And what this does is it actually just prints out like what book the user is reading. So it says reading. And then I'm saying this.title by this.author. And when I say this, that keyword refers to the title or the author for the specific instance of the class that's calling it. So that would be like the specific title or the specific author. And then down here, I actually created an instance of the book class. So I created a book object and I stored it inside of a variable. So here I'm creating a variable and I'm storing inside of it a book object. So when we create a variable, we define the data type. I'm giving it a name book1. I'm setting it equal to a new book object. I can just say new book. And then down here, I can give this information. So I can say like book1.title is equal to Harry Potter, book1.author is equal to J.K. Rowling. And then down here on that book1, I could call that function. So I could say book1.readBook, and that's going to print out reading Harry Potter by J.K. Rowling. So this.title represented Harry Potter, and this.author represented J.K. Rowling for that specific book instance. And then down here, I can print out the title, so we're printing out Harry Potter. And I can also print out the static attribute. So remember, the static attribute was defined on the class level. So I can just say book, this is the name of the class, dot static attribute. So with the static attribute, I don't have to create an instance of the book class in order to access it. I can just access it, like I said, at the class level, just like that. Now I want to talk to you guys about constructors. And a constructor is a special method that we can define in a class, which is going to get executed when we create an instance of that class. So up here in the book class, I actually created another little method here. It's just public book. And you'll notice that the name of this method is the name of the class. And when we name it like that, it means that we're creating a constructor. And again, this method is going to get called whenever we create an instance of the class. And over here, I'm having the constructor take in a title and an author. And I'm setting this.title equal to the title that got passed in, and this.author equal to the author that got passed in. This is just an easier way for us to initialize our objects with initial information. So down here, I created a couple books. Book1 is equal to new book. And you'll see here, when I say book right here, this is me calling the constructor. So since I'm calling the constructor, I have to pass it a title and an author. And then I'm just printing out the title. You can see Harry Potter. And then I made another one for Lord of the Rings. And it's important to note that you can have as many constructors as you want. So I could have a constructor that takes in a title and an author. I could have a constructor that just takes in a title. Or I could have a constructor that doesn't take in any information. You could have multiple constructors. So that's basically how you can use constructors to make your life easier. So now I want to show you guys how we can implement getters and setters in C#. Now getters and setters, it's actually a design pattern that we can use, which allows us to control access to the attributes of our classes. So up here in the book class, I added some getters and setters. And you'll notice a couple of things I changed. So up here, these two attributes, these used to be public, but now they're private. And that private keyword basically means that only code inside of the book class is going to be able to access these attributes. So if I have code outside the book class, for example, down here in the app class, I'm not going to be able to directly access those class attributes. So I can't directly access the title or the author. So in order to work around that, what we can do is create public getters and setters. So I have a method getTitle, and basically this is just going to return the title from the class. So this method is able to access the title because it's in the same class as the title, but outside we wouldn't be able to access it. So now if I want to get the title, I can just say like book1.getTitle, and you'll see I'm getting the title. And then also one thing you want to make sure that you do is over here in the constructor, whenever you're setting the title or the author, you want to make sure that you go through that setter. So now I'm saying this.setTitle, and I'm passing in the title. So that's how you can implement getters and setters in C#. All right, now let's take a look at another object-oriented programming concept, which is inheritance. And inheritance basically allows a class to inherit all the functionality and attributes of another class. So up here, I created two classes. I have a public class chef, and I have a public class Italian chef. So these are two chefs that I'm representing in my program, a general chef and then an Italian chef. The general chef has three methods. So it has a make chicken method, a make salad method, and a make special dish method. And basically all those methods do is just print different things out onto the screen. And then down here in my Italian chef class, I'm actually inheriting all of the attributes and functions and methods from the chef class. So I can just say public class Italian chef colon, and then the name of the class that I want to inherit from. And then now the Italian chef will inherit all the functionality from the chef class. And you'll see the Italian chef class has two methods. The first is a make pasta method. So the Italian chef can make pasta. And then the second is that make special dish method, which the Italian chef is overriding. So I'm going to come back to that in a sec, but I just want to show you guys down here. I created a chef object. I created an Italian chef object, and I'm having the chef make chicken, and I'm also having the Italian chef make chicken, and they're both able to do that. And you'll see down here, I'm overriding this make special dish method. So over here in the normal chef, I have a make special dish, and then down here in the Italian chef, I have a make special dish. And the way that I can specify that this can be overwritten is up here in this make special dish method. In the superclass, I can put this virtual keyword there. That basically means that this method can be overridden. And then down here in the Italian chef, in the subclass, I can put override here. And that'll basically tell C# that we're overriding a method from the superclass. And you guys will see now if I change this to make special dish, and I'll change this one to make special dish as well, they're both gonna make a different special dish. So the chef makes a special dish, and the chef makes chicken parm. So the chef just made a generic special dish, and the Italian chef made chicken parm. All right, now I want to talk to you guys about another concept with inheritance, which is using constructors and attributes. So over here, I have my public class chef, and this is just like what we had before, except now I'm adding in some additional attributes. So the chef can have a name and can also have an age. You see down here, I have a constructor, so passing in a name and an age, and then just setting them. Pretty standard constructor. And then down here in the subclass, so in the Italian chef class, which is inheriting from the chef class, I added in an extra attribute, which is country of origin. And so over here, I have the constructor, which I'm basically just defining, and then I'm taking in a name and age, and then that country of origin. So down here, I'm also putting a colon, and then I'm saying base, name, and age. And this colon is coming right after this parentheses right there. I just put it on a new line. And what this is going to do is it's going to call the constructor from the superclass. So when I say base and then I pass in name and age, this is calling the appropriate constructor inside of the superclass, inside of that chef class. So I don't have to initialize the name and the age. I'm going to go ahead and let the superclass constructor do that for me. But we still have this additional attribute, country of origin. So down here, I'm just saying this.country of origin is equal to country of origin. So that's basically how I could have attributes in the superclass and in the subclass, and then work with the different constructors. And then down here in the main function or the main method, I just have my chef object passed in Gordon Ramsay and 50. Then I have my Italian chef object, and I passed in the name, the age, and I also passed in the country of origin. And then over here, I can just say my Italian chef.country of origin, and you can see we get Italy. So basically all of that's working. And then also I could say like my Italian chef.age, and then if I reran the program, you'll see we get 55. So all that is wired up, and that's basically how we can work with constructors and attributes in inheritance in C#. All right, now I want to talk to you guys about another object-oriented programming concept of abstract classes and attributes. So over here, I created an abstract class. An abstract class is basically a class where you can specify specific methods where the subclasses have to implement them. So here I have this abstract class vehicle, and you'll see I have a public abstract void move method. So I declared this method, but I didn't actually give it any information. Like I didn't actually define the method. And then down here I have a public void get description. So this is another method which I gave information to. So this is a fully functional method, and this up here is an abstract method. And basically that means that any subclasses like this bicycle class or this plane class that I created, which are inheriting the vehicle class, are going to need to implement that. So down here in each one of these, like in this bicycle class, I say public override void move. So down here I'm overriding that move method, and you can see it just says the bicycle pedals forward. And then in the plane class, same thing, overridden the move method, and it just says the plane flies through the sky. So then down here, I can come down and create a plane object, and I could say like myplane.move or myplane.getDescription. And it says, for move, it says the plane flies through the sky. And for get description, it says vehicles are used for transportation. So that's kind of how we can use abstract classes and attributes and methods in C#. All right, finally, the last concept I want to talk to you guys about in C# object orientation are interfaces and interface inheritance. Basically, I can define a general interface, which is essentially a fully abstract class with all abstract attributes and methods. And then I can create subclasses which will implement that interface, and they'll have to implement all of the methods and stuff like that. So over here, I have a public interface animal, and I just defined one method, which is just void speak. And you'll notice that I'm not actually like giving this in any information. I'm not really defining it. And then down here, I have a subclass dog, which implements animal. And you'll see over here, I have a speak method, and I'm just printing out woof woof because that's what a dog says. And then I have another one for cat, which again, public void speak, and it's printing out meow meow because that's what a cat says. And then down here in my main program, I created an array of animals. So I said animal, I called it animals, and inside of this array, I put two animal objects. So I put a dog and I put a cat. Now I can put the dog and the cat inside of this array because technically they're both animals. And then what I could do is I could say for each animal in animals, I'll tell it to speak. And you can see over here, we run the program, and it's the dog barking and the cat meowing. So polymorphism or interface inheritance is really great because I can basically define a like overall interface, and then other classes can implement that interface, and then they're all considered to be the same type, which in this case was animal. So that's kind of everything that I wanted to touch on in this video. Obviously, I didn't cover everything in C#. I mean, you can spend hours and hours just going over the different things that you can do. But I think this gives you an overview of how to do a lot of the common things that you would want to do in a programming language in C#. And hopefully this kind of demystifies C# a little bit for you and gives you an idea of how it works, some of the conventions, and how we can do different things. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.